Hello everyone. So today should be our last video in Laplace Transform. So now that we have learned all the different parts, just want to do a quick review and then probably go over an entire problem from start to finish. And you can see this type of question take a long time to do and has so many parts that you have to pay attention to. It's really not something that you think that, oh, I'm just going to be able to do it without an intensive amount of practice. So keep that in mind. You do have to take a test on this. Okay, so you need to be able to do that all by yourself. All right, so let's try to solve this equation. So problem will probably say something like this: solve y double prime minus 6y prime plus 15y equal to 2 sine 3t with the initial condition, y of 0 equal to -1 and y prime of 0 equal to -4. And the question will be specified, we'll say using Laplace transform. So you do not get any credit for doing it any other way. Okay, and remember, this question is designed to test you on using Laplace transform. So remember that basically three parts to this type of problem using Laplace transform. The first step will be to apply Laplace transform on the differential equation. And solve for basically Laplace transform of y. And that second step would be to use partial fraction decomposition on basically L of y. So that way you can break it down into multiple partial fractions. And that's how you kind of use it to figure out what happened. And then number 3 basically would be to apply inverse Laplace transform to find y. And remember, you do have a table for that, but as you can see from last video, sometimes even with the table, you're going to require a little bit of adjustment to kind of make your fraction fit into what the formula is, and therefore then allow you to actually find out what the function is. So don't think that, oh, I have a table, should be okay, but it's actually not that easy to do either, even with the table. And precisely the reason why I'm going to allow you to use a table, because I don't want you to, on top of try to have to figure out how to fit into the table, but at the same time also have to kind of memorize all this formula. So let's go through this step by step, okay? So here we go. Let's start with our first step. So step 1, or first step, is to apply Laplace transform to this equation. So I'm going to take my equation, with my initial condition. Well, actually, I'm going to leave out the initial condition for now. I'm going to just do my Laplace transform. Okay, so therefore meaning I'm doing Laplace transform of y double prime minus 6 Laplace transform of y prime plus 15 Laplace transform of y equal to Laplace transform of 2. Actually, maybe I'll pull out the 2 to Laplace transform of sine 3t. Okay, so Laplace transform of y kind of stay. And the key is, what is 2 times Laplace transform of sine 3t? So then all you have to do is just go up to a table. So I'm going to try to write out the rules that we use while we're doing the problem, so that you can definitely refer to it. So here's the rule. The rule is number 5, which say that Laplace transform of sine bt is equal to b over s squared plus b squared. So compare that to that, I can see that b is 3. So therefore, that would tell me there's 2 times 3 over sine squared plus 3 squared, which is 9. Laplace transform of y would stay, because that's what we're going to try to solve for. So now the question is, what are Laplace transform of y prime and y double prime? Now, both of those you will need to memorize. Okay, so let's do that. So I'm going to go and say minus 6. Laplace transform of y prime is given to be y of 0 negative y of 0 plus s Laplace transform of y. Okay, wait. Maybe I'll write it a little bit bigger. Negative 6, negative y sub 0 plus s Laplace transform of y. There you go. And then Laplace transform of y double prime would actually be negative y prime at 0 minus sy of 0 plus s square. Oh, what happened? Maybe I do this. There you go. Now I have room. All right. So, and put s squared Laplace transform. Oops. Laplace transform of y. So now remember, these two you kind of have to memorize. You're not going to be given either of these two formulas for y prime and y double prime. I think that's the only formula that you have to memorize, which I don't think is too bad. So now let's see what happens. So now I'm going to try to clean this up. And remember, now the first step, the goal is to find L of y, Laplace transform of y. And we probably also want the other side to combine to one single fraction, which is what we're going to try to do. So therefore, on this side, I have 6 over s squared plus 9. On this side, if I collect everything, I should have the following. So let me see. Laplace y prime of 0, that is negative 4. So negative Laplace, negative y prime of 0 become positive 4. Y of 0 is negative 1, so therefore become plus s right here. So that becomes just 4 plus s. And negative y prime of 0 become positive 1. Okay, so if I'm looking at these, all of these correctly, I should have 4 plus s squared Laplace transform of y minus 6 minus s Laplace transform of y plus 15 Laplace transform of y. So it seemed to me that I would have s minus 2 plus, and we'll collect the Laplace transform of y together, s squared minus s, 6s, I'm sorry, missing the 6, 6s plus 15 Laplace transform of y equal to 6 over s squared plus 9. Remember that this part right here should kind of match your differential equation. If you do it right, which it does, it matches our the differential operator, our linear operator. And it's not by design, it's actually almost always, I would say for us, it always happens. Okay, so now it's just a matter of cleaning this up. So it seems to me that Laplace transform of y will simply just equal to, well, actually maybe I'll do this, 6 squared minus 6, s squared minus 6s plus 15. Laplace transform of y should equal to 6 over s squared plus 9. Was that minus s plus 2. So therefore, if I combine them together, I get this. So so what I need to do is 6. I guess I will put it this way, minus. Actually, I probably better write it this way, just to plus negative. So that way, make the sign work out better. That way, you don't make mistake. Like this. So if I multiply this out, that should be negative s to the third. Maybe I use red, so that would make it stand out. Negative s to the third plus 2s squared minus 9s plus 18. So if I combine them all together, and then I'm just going to divide the s squared minus 6s plus 15 on this side. Then the top seems to me that I will have negative s to the third plus 2s squared I do have minus 9s, but then the plus 8 and the plus 6 become plus 24. So these are s. All right. So that looked pretty good. So that kind of complete my part 1. Okay. Interesting thing to note here is that s squared plus 9 is definitely not factorable. It's a sum of two perfect square. And s squared plus 6s plus 15 is also not factorable, because the only two pairs of number that multiply give you 15, would it be 1 and 15 or 3 and 5? But since it's positive 15, that means they have to have the same sign. So neither positive 1 or positive 15 or negative 1, negative 15, actually in this case, would add up to negative 6, nor would negative 3, negative 5 add up to negative 6 either. So therefore, we actually have two quadratic factors on the bottom, which is going to be a little bit tougher for us to do. Remember, with quadratic factor, we kind of have to use a different strategy. Instead of kind of keep plugging in number that would make the one of the factor equal to 0, like we normally would do, we're going to have to try a different technique to do that. So meaning, instead of doing this technique right here, let me show you from our notes. Instead of doing this technique where you keep plugging in x equal to some value and then try to solve for things, with us, sometimes with the quadratic factor, it's easier to do something like this, where you pair up the coefficient. It will result in a simpler different system of equation to do. So we don't know what's going to happen with this one yet, but once we set up the our partial fractions, then we'll see. So now is our second step. We complete first step. So now second step is basically do partial fraction decomposition. So what I'm going to do is just focus on the fraction, and I'll attach it to the Laplace transform of y once we figure out what this is. So remember, because both of these are quadratic factor, are irreducible quadratic factor, remember, if it's reducible, you have to rewrite it into linear, because you're not going to be correctly breaking down the partial fraction if you don't. So in here, I only have two irreducible quadratic factor, therefore we'll form two partial fractions. One of them is this one, and one of them is this one. And because the quadratic factor on the bottom, the top will have to be a linear factor, so it become as plus b and cs plus d. And yes, I do like to use capital letters for those coefficients. So what would happen if I now do this? So therefore, meaning that negative s to the third plus 2s squared plus 9s plus 24 must equal to as plus b multiplied by s squared minus 6s plus 15 plus cs plus d multiplied by s squared plus 9. Okay? So now, nothing to it but multiply these things out and then see what's our best approach. So in this particular case, I would definitely say that plugging in x value is not going to help out, because it doesn't really make make any of these factors become 0 completely. So therefore, it doesn't help in solving for the value. So I would say let's just clean this up and then just pay up the coefficients. So I'm going to do that. So negative s to the third plus 2s squared minus 9s plus 24 is equal to, so if I multiply this out, that's as to the third minus 6as squared plus 15as plus bs squared minus 6bs plus 15b plus, multiply this out, cs to the third plus 9cs, and then plus ds squared plus 9d. So there are a lot of things going on, but remember, the beauty of linear algebra is that even though I look at the right side and my holy god, there's a lot of terms here, but they are all always going to combine into the following four terms. Remember, it's linear. Is basically an element in P3. P3. P3 is spanned by 4 basic vectors because P3 is 3-dimensional. It's 4-dimensional. So therefore, I just have to figure out what are the 4 basic vectors, and then their coefficient will now identify uniquely what this basic polynomial is. So essentially, we're treating both of these, even though they're both third-degree polynomials on the left side and right side, but we are kind of treating them as a vector in R4 being equal to another vector in R4. Okay, because remember, it's coordinate and basis. That's how that works. So negative s to the third plus 2s squared minus 9s plus 24 would equal to. So if I'm looking at it correctly, s to the third has these 2 coefficients, a plus c, s to the third. So I'm going to lightly just kind of cross them out so that way I know I counted them. Okay. Let's do s squared. S squared, I have negative 6a, I have b, I have a d. So therefore, it seems to me that I'll have plus, and yes, don't use minus because that's just confusing. Use plus, and then you have some negative, then they just stay inside. So become negative 6a plus b. Oh, that should be bs squared. I don't know why I say c squared. B, and plus d multiplied by s squared. So I'm going to once again lightly cross those out. So that one is gone, that one is gone, that one is gone. And then I'll move on to the s. I should have 15a minus 6b plus 9c. So therefore plus 15a minus 6b plus 9c multiplied by s. So once again, we'll lightly cross out those terms. And seem to me that I only have last 2 terms left, and that will be plus 15b plus 9d. And we'll lightly cross out these last 2 terms. Oops. Huh, okay. There you go. I don't know why that one is black. Alright. So that's it. So now what does that tell me is the following. It tells me that a plus c should equal to negative 1. Negative 6a. Okay, maybe I can write better. A plus c equal to negative 1. Negative 6a plus b plus d equal to 2. 15a minus 6b plus 9c equal to negative 9. And then finally, I have 15b and plus 9d equal to 24. So what we have here is a linear system. Okay? So now it's just a matter of trying to solve that system properly. So look like we have a system of linear equations. So what I'm going to do is I'm going to write it into a matrix form just so that it's easier for me to look at. So there you go. So now solving this system is not something that I want to focus on. You should be able to know how to do this by yourself. Multiple ways you could do this. You could definitely go through row operation. That would take you a while to do, but that's definitely something that can be done. So you can definitely do that. But my suggestion to all of you would be to do the following. So simply just realize that, well, if it is a matrix equation, then it definitely has a unique solution, which is just this. Which means, assuming that this has a unique solution, which I'm pretty sure it does, we should now be able to just use the inverse function, a matrix, to do that. Now, obviously, you might be thinking, well, find the inverse of that matrix is no easy task either. True, but then, technically speaking, your TI-84 can do that. Or if you have Inspire, you can definitely do that. So I'm going to say that you definitely allowed to use your calculator to find the inverse of this matrix and then just find the solution. So I'm not going to go through the process here because that would take too much time, but I'm going to just say that, assume that you have some way to find the solution. The solution from what I have is basically this. Okay, so therefore that tells me that A is 1 over 10, B is also 1 over 10, C is negative 11 over 10, and D is 5 over 2. So hopefully you get the same exact result as I do. And so now I think I'm ready to write out my partial fractions. Okay, so seem to me that my Laplace transform of y would actually equal to, was it 1/10 s plus 1/10 over s squared plus 9 plus negative 11 over 10s plus 5 over 2 over s squared minus 6s plus 15. Now that look all right, but it's actually not the best way to actually write this. So I'm going to try to rewrite it a little bit better, so that way maybe it's help. Okay, I could definitely do the following. If I'm looking at this correctly, I can actually pull out a 1/10 from all of them. Then what I have will be s plus 1 over s squared plus 9. And then this one would be negative 11s plus 25 over s squared minus 6s plus 15. So that's pretty good. And that would be what Laplace transform of y is equal to. So now come the third step. So the third step is now try to apply Laplace transform inverse to try to figure out what it is. Okay, so if Laplace transform of y is equal to 1/10 of s plus 1 over s squared plus 9 plus negative 11s plus 25 over s squared minus 6s plus 15, then now I just have to figure out what is y, and y, technically speaking, will be 1/10 Laplace transform inverse of s plus 1 over s squared plus 9 plus 1/10 Laplace transform inverse of negative 11s plus 25, 11s plus 25 over s squared minus 6s plus 15. Ooh, I have to make sure I don't confuse my s and my 15 and my 5. All right, so now how do I do this? Well, once again, use the table and just try to figure out what would fit into our table correctly. So I'm going to deal with these two separate Laplace transform inverse individually and try to figure it out. So here's my first one. So now if I look at the table, notice that we do have something that look like s squared plus 9. As a matter of fact, we used this before. Is s squared plus b squared on the bottom. So therefore tell me that it's probably 5 or 6. The problem is we don't have a rule that deals with a binomial on top. So therefore suggest that I'm going to have to do this. I'm going to split it. And so now I can see that this one right here would be using rule number 6, which say that Laplace transform of cosine bt is equal to s over s squared plus 9 plus b squared. So it seemed to me pretty clear that b must be 3 for that. So that one is nice and easy. This one, however, is a little harder because this one requires us to use rule number 5 instead. So rule number 5 say that Laplace transform of sine bt is equal to b over sine squared plus b squared. And we know that our b is 3. The problem is that would mean that in order to use this formula the way it is, I need 3 over s squared plus 9 squared. But we don't have that. So what we're going to do, we're going to multiply by 3 on top. But of course, as you know, to do that, I must balance it by multiplying a 3 on the bottom, which I pull out of the Laplace transform. So now that would now make it look like what number 5 would be. So therefore, tell me that this should come out to be cosine of 3t plus 1/3 sine of 3t. So that takes care of this one part, which is not too bad. Okay. Now let's do the second part. So the second part is Laplace transform inverse of was that negative 11s plus 25 over s squared minus 6s plus 15. So if you were paying attention to my last video, I told you that whenever you have a trinomial, you kind of have to form a completing the square to kind of get it into the right form. So we're going to do that. So s squared minus 6s plus 15 plus 15 is actually the same thing as s squared minus 6s plus 9 plus 6. 9 is half of negative 6 squared. That's how we know it's 9. And then I can say, well, that just becomes s minus 3 squared plus 6. So that means what we have is actually Laplace transform inverse of negative 11s plus 25 over s minus 3 squared plus 6. And now that should be pretty clear that we're looking rule 15 or 16. The toughest part to use these two rules is number 16. The reason why number 16 is hard because number 16 requires you to have the s minus a on top for it to work. Okay, so therefore meaning I have to have s minus 3 on top. And not to mention that I have a negative 11 in front of the s, so that also complicates the matter. So these are probably the biggest trouble that we have to face with to deal with that. So I'm going to go and try to do that now. So let's see if we can do this. So we know the bottom is s minus 3 squared plus 6. The top, what I need is this. I need to do this. I needed that so that I can have the s minus 3 so they can match with the s minus 3 on the bottom to use rule number 16. And I also have to have the negative 11 because that's the coefficient in front of the s, so I kind of stuck with that. So now the problem is that I just need to make sure that it still works out. So now if you think about it, that would basically mean is negative 11s plus 33. But we only have plus 25. So what I need to do is subtract 8. So therefore now what I have would be negative 11s plus 33 minus 8. And that come out to be negative 11s plus 25, which is exactly what we need to have without changing my expression. And so now with that being done, I can now separate and pull out the constant, of course. Okay, so I'm going to go and pull out the constant. So negative 11. And then what I have would be s minus 3 over s minus 3 squared plus 6. And I'm going to pull out the negative 8 also, minus 8. Laplace inverse of 1 over s minus 3 squared plus 6. And now it should be clear that this first one right here, we're using rule number 16. Which said that when I take e to the at cosine bt, the Laplace transform is s minus a over s minus a squared plus b squared. So now it's just a matter of figure out what a and b are. So in this case, it should be pretty clear that a is 3 and b is actually radical 6 because we need b squared to be 6. And for the second part, and I don't have to do anything because that matches perfectly. If I put 3 to be a and radical 6 to be b, then s minus a over s minus a squared plus b squared would turn into s minus 3 over s minus 3 squared plus 6. So don't need to do anything adjustment. The second one on this side is a little harder because this one would be using rule number 15. Well, not harder, but just require me to do a little bit of work. That would say that Laplace transform of e to at sine bt is equal to b over s minus a squared plus b squared. So I do need a b on top, and here this one is the same. It's a equal to 3 and b equal to radical 6. So in order for me to use this rule correctly, I do need b on top, which means I need a radical 6 on top. I don't have radical 6 on top. So what do? I make it. I'm going to say multiply that by radical 6 on top, but then I also have to divide this by radical 6 on the bottom to balance it out. And so with all this work done, now I have my expression. So this would basically equal to negative 11 e to the 3t cosine radical 6t. This will be minus 8 over radical 6 e to 3t sine radical 6t. So now I'm ready to put my answer together. So my answer will be y equal to 1 over 10. Don't forget, we have the 1 over 10. And then Laplace transform with s plus 1 over s squared plus 9, which is just cosine of 3t plus 1/3 sine of 3t. I think that's what I have. Let me see. Yep, that's what I have. And then now with the rest of them, and Laplace transform of these two would be minus 11 e to 3t cosine radical 6t minus 8 over radical 6, which is fine. Don't have to rationalize it. And so I guess I could say now my final answer, if I simply just distribute, I would have this. Um, 8 over 10 is 4 over 5, so I would say 4 over 5. So that's the best answer you can give me. Now, as you can see, just going through this problem takes us about 30 minutes. But of course, that's me because I have to explain a lot of things to you and go over a lot of the steps in detail. But it means that it probably going to take you that much time because you're not as proficient as with this type of question yet as I am. So it probably also still going to take you that much time to do it. So that means that you can barely finish this entire problem in one period on the test. And that's assuming you didn't make any mistake that would cause you to have to go back and double check. Okay, so as I told you, this is not going to be easy for you to do this kind of problem all by yourself on the test. It really will require a lot of practice on your part to make sure that you can do this. So we definitely have time that we can in class that we can go over more problems. Definitely work on the homework because the homework kind of separate them into multiple parts, smaller part for you to do, and then eventually put the whole thing together. That's it. I'll talk to you in the next video. All right? Okay. Talk to you guys later. Bye-bye.